Alkane, alkene, and alkyne. Alkene contains double bond, and the carbons are sp2 hybridized. As far as the stability is concerned, the tetrasubstituted alkene is more stable than trisubstituted, which is more stable than di, which is more stable than mono. For synthesis, for preparation of alkene, two major mechanisms are there, E1 and E2. E1 stand for elimination unimolecular, where the rate is depend on the substrate only. Two steps are involved. First step is slow, means loss of leaving group, creation of carbocation, and second step is fast, abstraction of beta proton and formation of alkene. The reactivity is tertiary alkyl halide is more reactive for formation of this alkene than secondary, and which is more than primary. Second mechanism is E2 mechanism, bimolecular elimination, where the rate is depend upon the substrate and the base. This is the one-step mechanism, which is also known as concerted, where leaving group leaves and the proton is also abstracted simultaneously. Reactivity is similar. Tertiary alkyl halide is more reactive than secondary, which is more reactive than primary to form this alkene by this E2 mechanism. There are two important rules. Sedgwick's rule, an elimination reaction, which says that the major product is more substituted alkene, and Hofmann's rule, which says that in elimination reaction, major product is less substituted alkene. Then this, if we try to see this E1 and E2 reaction mechanism comparison, the alkyl halide uh, reactivity is like this: tertiary, secondary, primary. Similar in E1 and E2. Base used in E1 mechanism is weak base and E2 strong base. Solvent used is polar in E1 type of mechanism and E2 polar aprotic solvents. And as far as the stereochemistry is concerned, there is no specific stereochemistry, but in case of E2 mechanism, the stereochemistry is specific. It's a stereospecific reactions where anti-periplanar orientation is required. The leaving group and the abstraction of proton, they should be opposite. So this is in short the whole story of alkene.